Today, we are going to learn how we can find the equivalent resistance of a particular circuit. So already the questions as well as the solutions are uploaded to the Google Drive and the links are available along with the description of this video. So you can check that to get the questions as well as the solution. So now let us look at this question. Find the resistance between points A and B. How can we do that? When we are asked to find the resistance between 2 points, that is from A and B, it means that we need to find out what is the resistance offered by this entire circuit when a current flows from point A to point B. Okay, so here if you look carefully, this is just identification of series and parallel circuits. Okay, so initial assumptions, still we can see that here a 6 ohm and 6 ohm are in parallel. Okay, and that network is in series with this 2 ohm. Again, similarly this 4 ohm and 8 ohm is in series because a same current is going through this 4 and 8 ohm. So this question is basically identifying which are series and which are parallel. Okay, so assuming that you have downloaded the questions as well as the solution, we can move on to the solution. So I'm going to the solution now. So if you look carefully, this is our solution. Okay, so now look, what is the first step? The first step is taking the parallel combination of 6 and 6. Okay, so when 6 and 6 are in parallel, the equivalent resistance is 6 into 6 by 6 plus 6, that is 3 ohm. So 2 ohm in series with 3 ohm. This 6 into 6 is converted into this 3. Again, 4 and 8 are now in series and this 2 and 3 are now in series. So 2 plus 3 will give us 5 and 4 plus 8 will give us 12. Okay, so if you just move down, we can see the circuit. Okay, 2 ohm which was earlierly present in the circuit, again 5 ohm and 12 ohm. Now 5 and 12 are in parallel and this 5 and 12 which are in parallel can be converted into a single resistance, that is 5 into 12 by 5 plus 2, that is we are getting the value of that as 3.53. So when you go to this, now this 3.53 ohm and this 2 ohm are in series. So the final answer for this particular question is resistance between A and B is 2 ohm plus 3.53 ohm in series, that is 2 plus 3.53, that is equal to 5.53. Okay, so RAB equal to 5.53 ohm. So this is the answer for our question number 1. Okay, so this entire circuit is now simplified into a simpler form of 5.53 ohm. I hope you understood this.
So this is our next question. So wait here, just look at this. So the moment we look at this, we can think that this is a Wheatstone bridge type of circuit. But in order for a Wheatstone bridge or circuit, the condition to be satisfied is that if you take this 4 ohm as R1, this as R2, this as R3 and this as R4, R1 by R2 should be equal to R3 by R4. Is it happening here? No. Why? 4 by 8 is 0.5 and 8 by 4 is 2. So the ratios are unequal. So that is not going to happen here. So we need to synthesize the circuit accordingly. So look carefully. What can we see? This 6 ohm is there, this 4 ohm is there, this 8 ohm is there. The one end of 4 ohm is connected to 6 ohm. One end of 8 ohm is connected to other end of 6 ohm. This 4 ohm and 8 ohm, the other ends are actually joined together. There is nothing in between the other two ends. That means that this is actually forming a delta. So we need to identify the equivalent delta. Okay, so we should take this as a delta and convert it to a star and then we should do it accordingly. Now we will be moving into the solution. Just look. So I am going into the solution of the second question. So look here. So this was my circuit. Okay. So I have just simplified it in this form. Okay, this 4, this end and this end, nothing is in between, so we can convert it to this form. Similarly, there is nothing in between 8 and 4 of this end, nothing is in between, so we can simplify it to this form. Okay, so now look carefully. We are going to mark 3 points, 1, 2, 3. Okay, we are going to take out this delta network from the circuit, and we have to converting it into a star. Okay, so look carefully. When you convert it into a star, what will happen? The 1, 2 and 3, these 3 particular points should remain as it is. Okay, when we are converting from delta to star, what actually happens is that the effect of the circuit won't change. We are changing a network alignment from delta to star in such a manner that the effect of the circuit does not change. So when you are converting from this delta to star, the values of the R1, R2, R3 should be adjusted accordingly so as that the previous effect does not change. Okay, so that is our aim. So this is our 4 ohm, 8 ohm and 6 ohm which we took from here. Okay, you can see that. Okay, so this 4 ohm, 8 ohm and 6 ohm is to be converted into a star. So from this is the 2 resistors from 1. Okay, that is converted into R1. That should be converted into 1. So it is not 4 and 8 in parallel. No, we are using another equation. What is that? R1 into R2. Okay, this resistance into this resistance divided by sum of the resistors. Okay, that is our R1. To find R1, we should multiply 4 and 8 divided by sum of all the resistors. You can find the equations in a reference textbook, but this is the simplest method to keep in your mind. Okay, so what happens is that R1 is 4 into 8 divided by 4 plus 8 plus 6. R2 is, what is R2? This is R2. Okay, this resistance is R2, that is 4 into 6 divided by 4 plus 8 plus 6. Okay, 4 into 6 by 4 plus 8 plus 6, that is 1.33. Similarly, R3 is this particular resistance, so that is 8 into 6 divided by 4 plus 8 plus 6. So we have found the values. Now what we have to do? We have found the star equivalent for this delta. We are connecting it back. One important point that we must keep in our care is that once we take out these 3 resistors and when we are putting it back, these 3 resistors are to be replaced. Okay, that means this 4, 8 and 6 need to be replaced by this network. How? Instead of 2, from a neutral point to 1 there is R1, from a neutral point to 2 there is R2, from a neutral point to 3 there is R3. So accordingly, when you change this particular circuit to that form, what we are getting is that we will be getting something like this. What is happening? The R1, R2, R3. Okay, this delta is changed to star, and the earlier resistors, the other resistors which were earlier there in our circuit will remain as it is. See, 4 ohm, this 8 ohm and this 4 ohm will remain as it is. Though the alignment, even their alignment does not change. Okay, I hope you understood. Okay, so here also what we are having is that we are having thus 1.78, 1.33, 2.67. They are replaced. They have replaced the earlier delta. Now this 8 ohm and 4 ohm and this 4 ohm is remaining in their earlier positions. Now see what is to be next step. When we are connecting it like this, current will come, it will come here, it will split into 2 parts. One through this 1.33, another through this 2.67. So what we see here, 2.67 is in series with 4. Why? The current which is going through 2.67 will flow through 4 ohm also. Okay, so these two are in series. Okay, 2.67 and 4 are in series. Similarly, look here what is happening here. 1.3, the current which is coming through 1.33 will go through 8 ohm. So 1.33 and 8 ohm are in series. Okay, so we can simplify the accordingly. So this and this in series, we can add them and we can get 9.33. 2.67 plus 4 will get 6.67. And what is the nature of these two resistors? They are in parallel. You can see these two resistors are in parallel. These two resistors, okay, they are in parallel. So we will find the equivalence of this parallel network. Okay, so what is that? It is 9.33 into 6.67 by 9.33 plus 6.67. So that will be getting a value. And what is the value? 3.9. And this 3.9 is in series with 1.78. It is also in series with 4 ohm. So finally what we can see? The total resistance RAB is equal to 4 plus 1.78 plus 3.9 equal to 9.67. I hope you understood the procedure of finding the equivalent resistance. Okay. So try to practice these two problems and you can contact me in case of any doubts. Thank you.